Here is how you prepare everything for a machine learning algorithm. I heard you are excited about new episode. Let's make this banger. Let's make a quick recap. We scraped the data, then we visualize it, and now it's time to prepare everything. I promise you, this is the final episode of preparing data for algorithm. Our mission for this episode is to concatenate, that means combine these two datasets into one dataset. This is our leaderboard. The placement is the variable we want to predict. It is our dependent variable, and others are the features from which we want to predict the dependent variable, so they are called independent variables. So without further ado, let's make the history. I will define function for all of these things. ML, algorithm, data preparation. As arguments of this function, we will use the two datasets, merge data frames, and the second one, leaderboard. The first thing in our labeled data, there are only 13 teams, and here are many of them. We need to find the common themes, the intersection between these two datasets. Then we cut off all the rows we do not need, and we will make one big dataset. Then we split it to the x and y. Y will be the last column of the dependent variable, and others will be the features. Finding common themes is easy. You can do it in many ways, but I wouldn't say the best way, but very efficient way is to use the built-in function intersection between the set of merge data frames, the column team name, intersection with the leaderboard, also only the column of team name, and this is not everything. Set is not very useful when you wanna operate over data, so I will make a list from it. But the set is here because we need one value, only one. There are no duplicates there. The second thing is cutting off the rows we do not need. So common themes merge data is equal to merge data frames. And in the first square brackets will be the condition, and in the second, like here, will be the columns we will be extracting from the original data frame. The condition for this will be from the merged data frames. I need only columns with team name. There are is in common themes. I will be using all the columns from this data frame as a feature, except of the duration of the game. The first will be my team name. As you can see here, I will just write there the names, win rate, wins, loses like this, the GPM, and the last one will be the standing. Yeah. I will do the same for the leaderboard, the data frame. The board is equal to leaderboard, and also the condition in the first square brackets, and I am using double square brackets for the extraction because I need more than one column. If I would need one column, I will use only the single square brackets for the extraction. Condition will be leaderboard, team name, only the columns, not only the rows which have the teams from the common teams, and I'll be extracting the columns with team name, and how it is called? It's called placement. Now we are having two data frames with only the rows we need, and we need to concatenate it by the names, not the indexes before the datasets. As you can see here, the fifth row. I need to concatenate not the fifth row with fifth row, but the fanatic with the fanatic. It is done like this. I will call it data for algorithm. There is one built-in function in pandas concat concatenating two data frames, and here I will specify which data frames. I will concatenate common themes merge data and set the index to the name of the themes. I will concatenate it with the leaderboard data frame. I misspelled something somewhere. Leaderboard like this. Leaderboard. Yeah, there's Borat. Hello. I am Borat. The board. Everything is fixed, and also I will set the index. That index to the team name. That's not everything. I need to write axis is equal to 1. It is concatenating by the columns, not the rows. I think number 0 or 2 is concatenating by the rows. I'm not sure which one. Then join inner. It is just to make sure it didn't duplicate the themes. And the last one is reset indexes. It is concatenated by the team names, but the indexes could be there, so I reset them and everything is fine. Now I have another mistake, because this is not highlighted. Common themes leaderboard, I will like this, and now return the data for algorithm. Call the function somewhere here, data for algorithm is equal to ml, this one, and I will put parameters merge data frames and leaderboard. Print out that everything is working. Oh my god, it's working. As you can see, we had two data frames, and now we have only the one data frame with common themes and required columns. What's the last thing we need to do? Yeah, you are correct. We need to change data type of the columns and then normalize the values. Normalization is to just pick a max value, then divide every value with the max value. So it is in the range from 0 to 1. You can use like minus the minimum, and then it is exactly from 0 to 1, but is okay. Just divide it with the maximum of the certain column. We are doing this because we need to make sure that every column have the same impact to the algorithm. As a next step, we are getting rid of this percentage sign and replacing this string to the integer. Not replacing, but changing, altering the data type. Same data frame. The column with win rate is equal to same data frame, same column, and there is another built-in function called .string.strip, and the character you want to strip from the string. If there are white spaces, it will delete all the white spaces. Now I need it as type integer. I checked it before. All of these are also strings, so I need to change everything to the integer values. It is done similarly to the win rate column. I will start with the GPM gold per minute. It's equal to pandas built-in function to numeric, and enter the data frame algorithm, the column, and there is another parameter. The second one is called errors is equal to coerce. That means if any value cannot be transformed into the integer, it will display none, not a number. I will do it for the other columns. Win rate. Do I need to do it for win rate? I will just make sure I will do it also for win rate. Pandas to numeric. Data algorithm. Win rate. Errors is equal to coerce. Data from algorithm for wins. Pandas to numeric. Same data frame. Wins. Errors equal to coerce. And the last one, data for algorithm. loses, pandas to numeric, data for algorithm loses, and the same second parameter. Now we change the data types, but we do not want to predict any value with the name of the team here. So we need to drop this column. Same data for algorithm is equal to data for algorithm dot drop name of the column and on which axis. If it's axis equal to 1, as I said before, I will delete all the whole column. There is one thing I will explain in the machine learning algorithm. You can check it. The machine learning algorithm will probably already be in the GitHub repository in the link bio. That's the thing. For our algorithm, we need data1, which is equal to 1. That's the starting point. So we basically add one column with all the ones. So data for algorithm is equal to pandas concatenate. I will concatenate that series of 1. I will concatenate like this. pd dot series of 1, and the index will be the same as in the data for algorithm, and the name will be equal to param0. Here I need to write data for algorithm, not here, but here I need to write data for algorithm because I need to concatenate these two, and here comma and axis is equal to 1 to concatenate the columns. Finally, we get to the point we have our data frame. The thing is, we are splitting it now to the features and one dependent column and normalizing the values. X will be our features data frame, this data frame algorithm, and drop last column. Columns is equal to placement, the last one, and Y will be data frame. We will do little slicing. Here is like from the 0th row to the every row. This first is slicing for rows and the second is slicing for the columns. And we need not slicing, we need only the 6th one. Like 0, 1, 2, 3, 4, 5, 6. Like we need only this dependent column. To normalize the value, I will do it like this. To x, I will apply an anonymous function. It is when you don't want to define another function because it would be overkill. Just make lambda for every column. Lambda x, every x divided by numpy max of x. This is apply is for one column or one array. So in our case it is for one column. I will return the x, y, and data for algorithm. Write it here like x, y, data for algorithm, and print the x and also the y. Why? It is time for showcasing that everything is working. Not everything is working. There is one mistake. I don't know where. It is in this series. I did a mistake there. There should be index, not like index should be equal to that index from the data for algorithm. Now I will try to run the code. Another mistake. Yeah, I forgot. For this slicing we need to use iloc. It stands for integer location. It allows us to do the slicing per time. It is working. Yeah, it is working. As you can see, we have our data for algorithm with the param 0, with the data 0 of series of ones. Then the x, the features, normalized by the maximum in every column, and there is not 0. Don't care. You can normalize it in other way, that you will have from 0, exactly from 0 to the 1, just we will do minus the minimum, but it doesn't matter now. This is good enough for us, and the dependent column. That's everything for this. In the next episode, we will be performing multivariate linear regression on these features to predict the final placement in the words. Stay tuned, smash the subscribe button, like the video, comment if something is wrong in this video, if you want to improve something, yeah, everything like this. And the most important, have a good day. Peace.